session. So in our last lesson we started discussing the tree traversal, and we introduced two very famous algorithms, BFS and DFS. We already implemented BFS. Using BFS we could traverse a tree, and today we will work on DFS, deep first search. So in breadth first search, the point was that we were checking all the nodes in the tree level by level. For example, from the root level, next level, and then next level. But with deep first search, we start from the root and go as deep as until the last node in one branch, and then keep coming back to the second branch and keep back to another branch until the last node in the tree. So we could implement BFS using a queue to keep track of the visited nodes, and in DFS we use a stack to keep track of the visited nodes. So now let's see how we can write a Java method for this. And before that, once there is a very good animation on Wikipedia, you can see that. See, DFS, so it is a search algorithm, and it starts from the root and goes until the last node in one branch, then comes to the second branch, then come to third branch, then come to until the last branch. And there are some more details. You can read it for yourself, but the whole point is we keep starting from the root and go until the last node. So let's write our DFS method. I'm saying that public void DFS, and I pass the root. So the first thing we do is we need to create a stack. We say stack of type node stack equals new stack, okay, and so let me create the stack here. Let's suppose it's our stack. We created that, and now we add our first node, which is root, to the stack. Actually, before adding that, we check if the tree is empty or not. If the tree is empty, if the root is null, then we don't need to do any operation. We just return that. So we say if root equals null, return it. Like that, we don't need to no operation, no wasting time. But if root is not null, then we add this to the stack. So we say stack.push. There is a method for stack.push, and we add root to the stack, something like this. For example, okay, so we added our root to the stack. So now we keep these our operations until the last node in the stack. So we say while as far as this stack is not empty, stack dot is empty is false dot is empty. As far as the stack is not empty, we have to keep keep checking the nodes in the stack. So right now there is only one node in our stack, and when we say is empty, it says it is not empty. It becomes true. So for example, the answer of is stack.empty is empty, it is false, but we use this negation, and that makes it true. So as far as as far as this condition is true, we can keep going on. So now we know, like, the stack works on first in last out, or last in first out. The point is that it is a stack, so the nodes that goes at the bottom of the stack they go first, and when we take them out of the stack, they are the last ones. So, and right now there's only one, and we take that from the stack. So we say node, I call it current, similar to the operation that we did in the BFS. Node current equals stack dot pop. So when I say stack dot pop, that means it gets the last inserted node in the stack, and that is 15. So when I say that, it happens like this. That means it is moved to the current. So now that we have in the current, let me actually, I can have it in the current so that you can see that. So I removed this from the stack and put that in the current. Okay. Put that in the current. So now I'm saying that now that whenever any node that we get out of the stack, we check that. We do the operation that we need. If you are looking for a specific node, we check the value. Or if we need any other operations, when we take that out of the stack, we check it. Right now, I only print that. I am saying system.out.print current.data. Okay, so when I printed this, that means when I check this, and then I have to go to one of either right or left child, and I have to go as deep until the last node. So first go to the, you can start from the right or left, that doesn't matter, that is the same thing. So let's check if it has a left or right child or not. So you say this removed node from the stack, which is current, you say if current dot left, that means if current dot left is against null, that means if it has a left child, which it has right now, so we have to add this left child also to the stack so that we could visit that also at some point. So we say stack dot push current dot left. So we added number 30 to the stack here. So now now we added number 30. So let's also check if it has a right child or not. So we say if current dot right is not null, that means it has a child, then we have to add that also to the stack. So we say stack dot push current dot right. So we added the current dot right also to the stack, that means 20. Okay, so I added current dot right also inside the stack. Okay, so and this loop continues checking. Again, at this point it checks, is this stack empty? Of course it is not empty. You see there are two nodes. So we say node current stack dot pop, and it takes the last inserted node. That last inserted node means 20. So when I pop this to a negative from here and put that in the current, okay, put that in the current, and now I check the current node, which I just removed that from the stack, and here you only print the data. So when we printed this data, which is 20, then we check does Tony have a left child or not? So we say if Karen dot left against null is not null, which it is not null, then we add this to the queue, to the stack, sorry. So now we add number 8 to the stack. So let me, so we added number 8 to the stack here, and also we check its right node. So we say Karen.right, if it is not null, so we have to add this also to the stack. Stack.push Karen.right, which is 5. So now you see I added that also to the stack. Now our stack looks like this. So this loop continues and it says, is stack empty? Again, it is not empty. There are 3 nodes in the stack. So I will keep them in order. At the end we can see them, the order. So if it is not empty, then remove the last inserted node from the stack. That means pop. It was 5, not 85. So we pop the last inserted node from the stack, which is 5, and put that in the current. Okay, now we put 5 in the current, and we check or whatever operation that we need, we do that. Here we are only printing the data. We print number 5, and then we check, does it have a left child? So of course we see that 5 doesn't have any left child, so it doesn't, here nothing happens now at this point. And it goes to the next line. It checks Karen.right, does it have a right child? So again you see that it doesn't have a right child, so nothing happens here again. So the loop continues. Is the stack empty? No, there are 2 nodes. So if it is not empty, then take out the last inserted node. So we say stack.pop. The last inserted node is number 8. So we got number 8 in the current, and now we print it and then check its child. So number 8, does it have a left child? No, it doesn't have a left child. Does it have a right child? No, it doesn't have a right child. Nothing happens. So the loop continues. Is the stack empty? Still, the stack is not empty. There is 1 node. So if it is not empty, then take out that last node. So we take number 30 also. Okay. So we got number 30 also. Then we print its data and then check, does it have a left child? Number 30. So we see it has a left child, which is number 15. Then if it has a left child, then add this to the stack. So we add this to the stack. Now let's add this to the stack. Which is 15. So we added number 15 to the stack, and we check its right child. Does it have a right child? Yes, it has a right child. So add this to the stack. So we add this also to the stack. That is number 10. So we added number 10 also to the stack. And then this loop continues. It says, is the stack empty? No, it is not empty. Then take out the last inserted node. The last inserted node is 10, and put that in the current. So then we print its value and then check, does it have a left child? Number 10 doesn't have any left child. Does it have a right child? No, it doesn't have a right child also. So the loop continues. It checks, is the stack empty? Again, it is not empty. There is 1 node. So check out, pop. So we got number 15 also. Okay, so then we print number 15 and then we check, does it have a left child? So we don't see any left child here. Does it have a right child? No, it doesn't have a right child also. So at this time, when it says is stack empty, it says yes, and then it makes it false. Then this loop stops here. And see, here you could go through every node using this stack, and now see the order that you have visited. You visited number 50, then you visited number 20, then you visited number 5. That means you came to the until the last node. Then you started backtracking. So the second one was, so you from this last branch you came to the second last branch, which is number 8. You check number 8, and then this whole site finished checking. So it, the second time we're starting from the root, so you check number 30 and again 10, and until the last node is checked. So now let's test this in here and see, does it really check every node or not. So we say tree.dfs, so tree.root, yeah, see, let me add a space between each of them, system.out.print. So after that, print a space line also, something like this. And also you can add this, yeah, see, 50, 25, 8 until the last node. So with BFS also you can say only print, not print ln, print something like this. System.out. Okay. So you see the order is different with breadth first search and depth first search. So with the breadth first search, it was level by level. If you check, for example, number 50, then number 30 and number 20, see, number 30 and number 20, then the third level. But with DFS, we went as deep as possible. So I hope it was clear enough to understand how to implement BFS and DFS. There is one more optimized approach to implement DFS, which is recursive approach, and I will do that in the next episode. So until the next lesson, have a nice time everyone, and if you have any questions, add them in the comment. I will go through your comments. Have a nice time.